So welcome everyone. My name is Bob Odell. I'm the Senior Manager of Product Management for AWS Elastic Beanstalk. Today's webinar will talk about running a .NET application with AWS Elastic Beanstalk on our Windows Server platform. So what this session will cover, we'll go through a basic introduction to AWS Elastic Beanstalk. We'll look at a deployment of a .NET application on Elastic Beanstalk Windows Server platform and some of the features associated with that. A couple features that we'll focus in on are new to our Windows Server platform, and those include things like application health monitoring, as well as our Windows Server patch management. And then last, we'll save some time to we'll review some or go over some Q&A. So first, I thought we'd look at what does it mean to run an application on AWS. And it's more than just about writing good code. It really encompasses steps such as how do I provision the resources that I want to run my code on? How do I configure those and tie those together so that I create a platform which then I can deploy my code onto? And when deploying my code, I want to make sure that I'm doing it in a very safe way so that I'm not impacting previous, versions of my running application. And then last, once my code has been safely and successfully deployed, how do I manage that application and how do I monitor it for ongoing issues? And if you think about these steps, think through how are these handled today in your current organization. So are they split across teams? Do you have a group that focuses on the provisioning or things like infrastructure as a code? Do you have your developers that do the deployment? And then do you have an operations or an administration group that then does the management and the monitoring of that application? Or in some organizations, which maybe yours is it more of a DevOps workflow where developers are really expected to handle each of these various steps to running a web application from end to end? So regardless of the organizational structure or the workflow that you're using, AWS has a lot of services that can really help you run that web application today. And these are each individually very powerful services and very simple to use. And they're things like for compute, we have EC2, we've got Lambda, we've got ECS and EKS. For storage, you can store things durably in services like S3 or EFS. Databases, you can connect into RDS or DynamoDB or Aurora databases. We've got networking services to help you tie things together with elastic load balancing for scalability and high availability. And then we've got a set of management tools for things like CloudFormation, which lets you do infrastructure as a code, or systems manager for some of the patching and ongoing kind of monitoring and management of your systems. And again, while each of these is very powerful and simple, running a web application really requires that you learn each of these services, and it leaves that selection and the configuration and the management up to you. And that's really where Elastic Beanstalk comes in. So Elastic Beanstalk is the easiest way to get your application up and running in minutes. So today, Elastic Beanstalk supports running your web app on EC2 instances and on ECS for containers. And we really handle everything from end to end for you. We handle the provisioning and the configuring. We handle the deployment. We handle things like the load balancing and auto scaling configurations. We help set up your network and security. We leverage application health monitoring, and then we leverage a set of analysis and debugging tools for the management aspect once your code's deployed. The great thing is there's no additional cost for Elastic Beanstalk. You only pay for the AWS resources that make up your application, and you control all of the resources. So when they're provisioned within your account, and you've got full control with nothing shared across any other accounts. So before we dive into each of those, I wanted to talk a little bit about the Elastic Beanstalk model and help kind of set an understanding of some of the components that make up a Beanstalk application. So at its core, Elastic Beanstalk has applications and environments, and an application can contain multiple environments. So a couple ways to think about that is think in terms of a microservice. So you could have an application for your store, your digital store, that's composed of multiple environments, such as Go for your store front end or Python for your inventory and account services. And all of those are modeled within your digital storefront application itself. Another way you could think about it is if you have more of a monolithic application structure, you could have various stages. So you could have a development environment, you could have a staging environment, or you could have a production environment. And each of those environments has different settings. So when you deploy your .NET code, it's actually deployed onto an individual environment itself. And there's two types of environments that Elastic Beanstalk supports. There are single instances and there's high availability. And then we also provide deployment and health notifications both through the Elastic Beanstalk console as well as through Amazon SNS. So another concept that Beanstalk employs is the concept of versioning and rollback. So every deployment is its own unique version, and all of the versions are stored in your Amazon S3 bucket that's created when you create an Elastic Beanstalk application and environment. And what this allows is easy rollback to a previous version without having to go through your source control or committed code changes. You could instantly, in case of a failure or in case of an issue that you recognize, roll back to that previous version and then take the time to go through your source control to figure out where that root cause was. Having these concepts also allow you to promote versions across different environments. So if you've got an application set up with a development stage, you could easily do your testing there and then promote that into your test or QA stage, and then further promote that into your production stage. And then, of course, you can do an easy rollback at any point along that process. So Elastic Beanstalk supports today's kind of most popular runtimes, including Docker images, PHP, Java, Go, Node, Python, Ruby, and it also supports .NET, and that's .NET Framework as well as .NET Core that I'll share a little bit more details about here. So when you deploy a .NET application, it's actually deployed on a Windows Server platform. And today, Elastic Beanstalk offers the latest supported platform versions consisting of Windows Server 2016, Core 2016, Windows Server 2012, Release 2, with IIS versions 8.5 to 10.0. And all the latest .NET platforms are supported as well. So we support the .NET Framework 4.7 and above, and .NET Core 2.1 and 2.2 version. Or a .NET Core application to Elastic Beanstalk, you can do it in one of many ways. You could use the Elastic Beanstalk console, which we'll walk through an example of what that looks like. You can use the Elastic Beanstalk or the AWS CLI, or you can use the the AWS Toolkit for Visual Studio. So there's a plugin that allows you to go directly from Visual Studio to a deployment model directly into Elastic Beanstalk. Recently, we actually just announced a preview where you can do that same deployment model in VS Code. Once you deploy that, Elastic Beanstalk provisions all the necessary infrastructure resources, including the EC2 instances, the security groups and load balancers, and the auto-scaling groups. And it allows you to configure Route 53 with a domain name that you can configure and then set up your own CNAME mapping to that Elastic Beanstalk domain. And this process really is built to allow you to safely deploy your code within Elastic Beanstalk. So one of the easiest ways to get started in testing is if you've got your .NET application in your local IDE, you could actually use the Elastic Beanstalk CLI to get up and running in a matter of minutes. And the prerequisites that this would require is that you've got Python 2.7 above or 3.4 and above, and that you've got the AWS command line installed. With that, you'd have to make sure you've got your AWS account and your IAM role or your credentials set up to be able to do command line logins. Once those prerequisites are met, it's really as easy as installing the Elastic Beanstalk CLI, going into your local project directory and running really two simple commands. You could run what's called eb-init, which will create your application, and then you could do eb-create. And what will happen there is the eb command line will basically package up all of your code within that project directory and send it to Elastic Beanstalk, and then do all of the provisioning and configuration of those resources. Within typically 3 to 5 minutes, you would get response back with a URL that basically shows your application up and running live in AWS. Any changes that you would make to your code at that point could be pushed to that application using a simple command called eb-deploy. And updates are usually applied within 1 to 2 minutes of deploying those code changes. So it really is that simple to get up and running using the eb CLI with your .NET application. So additionally, if your build process for your .NET application creates a zip file, you can bring that zip file directly to the Elastic Beanstalk console and upload that as your source bundle directly into your environment that you're creating. And the .NET application is supported when creating a web server environment. So within the console, when you create an environment, go ahead and select the web server environment. And then one of the first things you'll do is give your environment a name. After you name the environment, you'll go ahead and provide a host name, which will then be associated with a Elastic Beanstalk subdomain representing the region, and then the domain name of elasticbeanstalk.com. And what that does is it allows you to map your own DNS names through a CNAME to this Elastic Beanstalk name that you have set in the environment creation. You can then give your web server environment a description and then select the .NET Windows IIS as your platform. And then you could click to upload your code at that point. It's really that easy to get started, but what I'd like to do is walk through some of the configuration options. I could create the environment directly from here and take the defaults that Beanstalk has, but let's take a look at some of the options that are available. So from within the configuration, one of the options we'll look at is instances. So you can see we've got a tile specifically for instances, and we can go ahead and click on modify what those are. Some of the other options that are available that we'll look at are things like what is our monitoring option settings, what are our deployment option settings, and then last we'll take a look at what are our managed update option settings as well. So within the instances configuration, for .NET applications, the default instance type is a T3 medium EC2 instance, and the default root volume size is 35 gig. What you'll want to do is based on your application and the footprint that you expect, you may need to change those, and these could be done during the initial setup, but they could also be done at any time throughout the application lifecycle as well. For instances, today we support a wide variety of instance types, all the way from general purpose to compute optimized to memory optimized. And then, of course, you can set the size of your root volumes and any IOPS that you want to see. If we go back to the configuration, once we're happy with our instances, let's take a little bit of time to look at the monitoring available. And this is actually one of the new features that we recently released for our Windows Server platform. So within the monitoring tile, we can see there's an option now for enhanced health. Previous to January's release, we only had basic health available. But enhanced health really brings a greater level of monitoring for us, including things like application latency. It looks for HTTP status codes from 200s all the way to 500s. And it even gives you the ability to ignore or filter out the 400 client-side error messages if you've got testing or canaries set up that potentially generate those in your kind of .NET application. Enhanced health also helps us look at instance status. So with enhanced health enabled, you'll have statuses that range all the way from okay all the way up to severe, and you'll see those on an instance by instance setting. And then last, you'll be able to see things like individual instance health around CPU and memory type settings. And all of these can be easily enabled with the single click of a button. It's important to note that enhanced health isn't available for Windows platform using versions of IIS earlier than 8.5. Also important to note that enhanced health requires that the IIS logging's configured with a W3C format in the ETW event only, or both log file and ETW event destinations. So if we go back out once we've set our monitoring configurations and really take a look at our deployment methods, this is another area that we have recently enhanced for our Windows Server platform. So let's go ahead and take a look at the rolling updates and deployment tile. You'll see in here for the deployment policy, and this is actually showing a high availability mode. High availability mode has 4 different deployment policies. They consist of all at once, which means when you deploy your code, it goes to all of your instances simultaneously. We also have a deployment policy called rolling, and that deploys code to a batch of instances at a time, and you can set that batch size by either a percentage or a number of instances. So if in high availability you've set up your fleet to be 10 instances, you could choose to have your batch set to either a percentage, or you could say deploy it to 2 instances, evaluate the health, and upon a good health determination, go ahead and deploy it to the next batch in that fleet. We also have rolling with additional batch, and the difference there is rolling with additional batch will, at time of deployment, it will take your batch size and spin up a completely new set of instances to deploy your code to. So in the previous example, if you had a total fleet size of 10 instances and you had a batch size of 2 instances, you would upon initial deployment have a fleet size of 12. Basically, we would create another batch of those 2 instances, deploy your code, and then if it was healthy, we would go ahead and deploy it to the rest, and the last 2 then we would end up dropping. And what that does is it ensures that you have a consistent availability of your application without any potential to degrade performance. And then our last deployment type is what we call immutable. And immutable deploys code to new fleet of instances and terminates the new ones. So again, in that 10 fleet size, we would go ahead and spin up 1 new instance, deploy that code to. If that worked, then we would spin up the rest of the fleet, deploy that code onto there, and once that was successful, we would then go ahead and delete the old fleet, so you'd be running on a completely new set of instances. If by chance you're running in single server mode, Single server mode only supports the all at once or the immutable since you've got a fleet size of 1. In addition to your deployment policies, you can actually also set your update size as well as any of your deployment preferences on when to roll back and the timing to look for those. So here's just an overview of the different deployment policies, all at once, rolling with additional batch, and immutable. And you can see these are really meant for different types of environments. So, the impact of a failed deployment for all at once would mean that you experience downtime. So all at once is really good if you're in a development stage or you're in a testing stage and you really want to do a quick deployment to be able to test that, but you're really not worried about, am I going to experience downtime if there's an errant deployment or if there's an issue with my code. At the far spectrum of that is the immutable, which is really a production-ready deployment policy. So immutable, if there is a failed update to it, it's caught immediately without impacting your current application or your current workload because new instances are spun up. And then rolling with additional batch are kind of in between there. But this is really a way to allow developers to test quickly in certain stages, but then also ensure that they've got very safe deployments for production applications. So if we go back to the configuration screen, one of the last areas that we'll look at are our managed updates. And again, this was one of the new features that we recently rolled out with our new Windows Server platform. So let's go ahead and take a look at some of the details and the features associated with our managed updates. So managed updates really allow you to, one, set a weekly maintenance window. So if you've got something already established within your organization, you can set managed updates within Elastic Beanstalk to follow that same maintenance window that you've got established. If not, you can go ahead and create one your own based on your traffic and your users' behavior patterns, so that if there is an issue, it will have the least amount of impact or can coincide with some of your on-call times. And managed updates, you can set really two types of updates. You can set it to do both minor and patch versions, which follows the semantic versioning, or you can do patch only. One of the other kind of unique options is even though your maintenance window runs weekly, typically we see, of course, Microsoft patches come out on the monthly basis. But some customers have requested to be able to, hey, weekly, I would also during my maintenance window, regardless of if there's a patch or not, I would like to basically have my instances running my .NET application replaced. So we've got a new feature that's called instant replacement that if checked, basically during your maintenance window, Elastic Beanstalk will go ahead and refresh all of your instances running your current application. And managed updates uses an immutable deployment policy. So we take the safest approach in bringing up a new instance each time we either do a refresh or we deploy a minor or patch version so that we don't impact your current running application. So that's a new feature that we rolled out with our last Windows Server update. But let's go ahead and now that we've selected all of our options, let's go ahead and create our environment. And again, I wanted to just say that a lot of these are set by default. You wouldn't necessarily have to go through the configuration settings that we had. But I wanted to be able to show you what some of the options were available. And these, again, could also be scripted through the command line or through an API or a plugin so that they could be done as part of a workflow as well. But once you've got your environment set that the way you want, you can simply go ahead and click on the Create Environment button. Once you click on the create environment, you'll actually see Elastic Beanstalk going through the configuration and provisioning process. So Elastic Beanstalk will begin to provision all of the resources that you specified, running the instance types that you selected. We'll apply all of the configuration settings, the enhanced health settings, any of the load balancing or fleet size settings will be applied. And then we'll deploy your code on top of that. And once your code is deployed, we'll go ahead then, and as a last step that you'll see during the creation process is we'll set up all the monitoring and the health status checks. So you'll be able to see as each of these different processes are done, you'll be able to see those visually on the console. So at any point, you know what's happening and what's going on. Again, all of the resources that are created and provisioned are all done within your AWS account and within the region that you specified. So it is a high control, full ownership model that Elastic Beanstalk utilizes. So within 3 to 5 minutes of creating or clicking on the create environment and going through the configuration and the deployment and setting up the monitoring, you'll basically have your application up and running. It'll be deployed, and what you'll see as highlighted here at the top is you'll see basically the URL with the host name that you supplied, followed by the subdomain, which is the region it's deployed in, and then last, the elasticbeanstalk.com. And that URL could then be used within your own DNS, basically to map your DNS to that Elastic Beanstalk URL. But you'll see here, this is kind of a typical overview of what the application up and running looks like. You can see a health status, you can see the version of code that's running, and you can see the platform configuration that's running on, as well as any of the recent events that have occurred within your application. Clicking on the link, because this was a sample app, will take you directly to the URL running in your browser, and you can see here we've got a congratulations sample app, .NET sample app up and running. So back in the environment screen within the Elastic Beanstalk console, the last thing we'll take a look at here is really the health and the monitoring screens. These will be probably, other than the configuration settings, two of the most used pages for an Elastic Beanstalk environment or application. So if we look at the health screen in there, the health page within the Elastic Beanstalk console, this is where you'll see the enhanced health statistics. So this will show you all of the running instances that currently are running your application code, and it'll allow you to monitor metrics such as the instance state. And you can see, again, those states range from okay to pending to informational to unknown, all the way up to a degraded and a severe status. The Elastic Beanstalk documentation has what each of those statuses reflect. But in addition to the status, you can also see some of the detailed metrics. So you can see the requests that are coming in and what HTTP errors are being received. You can look at any of the latencies across kind of pattern, and then you can look at your CPU utilization. So this page really lets you understand the health of your application at a very detailed level and allows you to interact with that. And another example would be if you had multiple instances running at this point and you saw one of them was in an unknown state, from within the screen, you could actually go into that instance and choose to either reboot that or replace the instance entirely. And again, Elastic Beanstalk would do that in a way to minimize any impact to your running application. So one of the other screens that we automatically enable for you is the health monitoring. So the health monitoring really brings up a set of CloudWatch metrics. These are automatically enabled as part of your Elastic Beanstalk deployment. You could actually see these running in your CloudWatch console, but we pull these into the Elastic Beanstalk console for visibility and really kind of a single view of your running applications. One of the other features that we enable within health monitoring is an easy way to turn on X-ray. And AWS X-ray really enables kind of a deeper level of analysis and debugging all the way down to a trace level. So if AWS X-ray surfaces a problem, you could easily click through into the X-ray console and look at deep trace level information for an issue that may occurred. And this is really kind of a home to, again, give you a good idea from an overall application perspective. You know, what is the trend? What is the graphing? And what does my application history look like? So Elastic Beanstalk doesn't stop with just deploying your application individually. We actually extend that into a CI and CD workflow. And today, you know, if you think about how can I create a very robust but simple CI/CD across my release stages, all the way from development to staging to production, with increasingly safer deployment status and reporting, as well as ongoing health monitoring. Elastic Beanstalk, in combination with our AWS code services, such as Code Commit, Code Pipeline. So Code Commit is AWS's source. It's a fully compliant Git source code repository. AWS Pipeline helps you orchestrate basically going from source all the way deployment into Elastic Beanstalk. And then if your application has any build steps, AWS Code Build will allow you to easily build your application as you've specified in a build spec file as well. So this really lets you go into a workflow where you're committing code into a source repository, which is then being picked up and automatically deployed into Elastic Beanstalk. AWS Code Pipeline also allows you to stage that. So back to the Beanstalk concepts of staging, if you've got an environment stage for development, you could have AWS Code Pipeline go directly into that development environment. Once that is up and running and verified, it could then automatically shift that traffic into a staging or productionally into a production environment itself. So one of the benefits of AWS is really the services themselves are building blocks and are plug and play, which allows us to take a systematic approach to CI/CD tools and the methodologies, and allows you to leverage your existing investments today. So if you've already made investments in a Git source code repo, such as a GitHub repository, or if you have a pipeline through CloudBees Jenkins pipeline, you could actually leverage those investments and still, for instance, a Jenkins pipeline, you could use an AWS Code Build plugin to deploy directly to Elastic Beanstalk. So it truly is a plug and play where you can leverage investments that you've already got, or you can start from an AWS kind of centric CI/CD workflow directly. So really, in summary, you know, AWS Beanstalk provides probably one of the easiest ways to get your .NET application up and running in minutes. And again, you can do that using the console, the Elastic Beanstalk console as we walk through. You can use that doing the Elastic Beanstalk CLI example we walked through. Or again, you can use the AWS Toolkit in the Visual Studio plugin or the VS Code preview that's available today. Applications can contain multiple environments, and again, those environments can be individually configured based on your application needs. And really the two use cases we see most often are microservices strategies. So if you've got a application that's made up of multiple different services, environments could be those services. Or if you've got more of a monolithic structure to your application, environments could represent your staging all the way from development to production. And Elastic Beanstalk really fits with the model that you're currently using or the model that makes the most sense for you. Another highlight that we talked about was being able to automate the Windows Server patch management and being able to opt into managed updates both at the patch level as well as at the minor level. And with that, being able to set designated maintenance windows and also being able to instruct Elastic Beanstalk to do instant refreshes even in cases where there aren't any patches that will be applied during that maintenance window itself. And then the enhanced health. So being able to monitor your application on several key health metrics, including HTTP status codes, including latency and CPU metrics and utilization, and then being able to see those on an instance by instance level and being able to take action on health statuses that are outside of an okay and up and running, up and fully running status. And then last, how easy it is to really extend your application deployments to Elastic Beanstalk through a DevOps or a CICD tool set. And that could be composed entirely of AWS services such as Code Commit, Code Pipeline, as well as Code Build that deploy directly into Elastic Beanstalk. Or those could also be a plug and play nature where if you've made existing investments, you could augment those with AWS Code Suite services and again, use Elastic Beanstalk as your deployment target. And with that, I'd like to thank everyone for attending today and open to taking any questions. Again, my name's Bob Odell. I'm the Senior Manager of Product Management for Elastic Beanstalk and wanted to share if anyone has any follow-up. There's our forum address as well. But thank you very much.